I'm just going to run down the list. These are all people who are familiar to you, but nevertheless, it's a great pleasure, even on my part, to welcome everyone. Howard Lutnick, America's Commerce Secretary, Rachel Reeves, UK Treasury Minister, Sean Banyo of Canada, Brian Moynihan of Bank of America, and Janet Trunkali of EY. So we have an extraordinary blend of powerhouse expertise in economic policy and private sector representation as well. I mean, I'm going to start with the public policy issues that are on everyone's minds right now that bear directly on the issue of sovereignty and interdependence. And I'm going to turn, with your permission, to Secretary Lutnick to give us maybe an insight and explanation. I think a lot of people are looking at Davos to see and to try and better understand the mindset of the Trump administration. Speaking to you earlier on, it's the first time I've had the privilege of meeting you. I've seen you on TV a lot. In person, the impression is even more overwhelming. Of, on the one hand, kind of extraordinarily ebullient, dynamic.
That was in a nice way, Howard.
Dynamic. These are good words. These are all good. I'm coming to a different tone in a second. But like initially, it's this just extraordinary ebullience. Dynamism. You were saying you've sealed deals for $1.5 trillion in jobs and investment into the United States.
Yes.
And then you said, and this is where the tone shifts, you got to understand, I'm the hammer. These were your words. I'm the hammer. Because the people I'm dealing with know that unless they deliver the kind of investments I'm looking for, I'm coming with 100% tariffs. And that duality, I think, between the dynamism, the constructiveness, the forcefulness of the American state, which was, after all, also something many of us saw in the Biden administration, and this element of threat, is what many of us are actually trying to come to terms with. Because this is, to say the least, unfamiliar. And when it moves from the zone of economic policy to the question that is directly under the subtitle of our talk today, which is sovereignty, and we're talking about the territory of Greenland, and it's coupled so directly to tariffs, it's a fundamental shock to the system. You can read it off the faces and the rhetoric of every single European politician and business person I've spoken to while we've been here, and we're also getting reactions from around the world in similar tones. So I really wanted to ask you to help us understand, not in a sense what your motivations are, because I get it, like you want Greenland, it makes sense. You're proud Americans, you're advocates of President Trump's policy. What I'm struggled more with is how you imagine others react to this. I mean, if you put yourself in the position of your Danish counterpart, who's a proud Dane and a loyal executor of the Danish government's position, how do you envision this going, how does this go down?
Well, I think you should start at a much higher level.
Okay.
We are in Davos at the World Economic Forum. And the Trump administration and myself, we are here to make a very clear point. Globalization has failed the West and the United States of America. It's a failed policy. It is what the WEF has stood for, which is export, offshore, far shore, find the cheapest labor in the world, and the world is a better place for it. The fact is, it has left America behind. It has left the American workers behind. And what we are here to say is that America First is a different model, one that we encourage other countries to consider, which is that our workers come first. We can have policies that impact our workers. Sovereignty is your borders. You're entitled to have borders. You shouldn't offshore your medicine. You shouldn't offshore your semiconductors. You shouldn't offshore your entire industrial base and have it be hollowed out beneath you. You should not be dependent for that which is fundamental to your sovereignty on any other nation. And if you're going to be dependent on someone, it darn well better be your best allies. Okay? And so that is a different way of
taken all this worldwide system, which you want us to give you all the You know, last week for a meeting of G7 plus a few other finance ministers to talk around critical minerals. Now, you do have some reserves of critical minerals, but not everything you need. 90% of your critical minerals at the moment come from the US, from China. You need to wean yourself off those.
Sure.
Yeah.
The United States of America is over 5% in the first quarter of 2026. That's just my opinion, but so far.
America. Secretary Lutnick, you said that globalization had failed the West and failed the United States, and you said it's left America behind. So I'd be interested to know some of the ways that the Bank of America and EY have been left behind in this set of circumstances that you're describing.
Ravi.
Hi there, Ravi Agrawal from Foreign Policy Magazine. Secretary Lutnick, I thought your first answer was illuminating about what America First is, and you framed it partly as an expression of sovereignty. And I guess my question to you is, what about the sovereignty of other nations? And this is linked to your role because the threats on Greenland are no longer hypothetical. You're already proposing economic warfare against 8 European countries. So how does this add up? Does sovereignty matter or not?
So I'll try to start on this side, which is when we launched our tariff regime on April 2nd, the world was aflutter with all of these kind of comments. But since then, if you check at the end of 2025, you will see all of the key indicators are up. The UK stock market's up, Europe's stock market is up, Japan is up, Korea is up. They are all up because, as it turns out, there is much more stability in a strong America and a natural and long-term relationship between two countries. I think with respect to the tariff policy, the president uses tariff policy to make sure people are talking and paying attention and not just acting. You have seen him use tariff policy again and again to have outcomes that are reasonable and appropriate. So the fact that he doesn't want things to be done without discussion and without consideration is a way for him to say, hey, you need to talk to us. If you're our great ally, you need to talk to us. Do I think the trade deals that we've set with Europe, with the UK, are they durable? I absolutely do. I do not see a model where Europe would decide, I want to blow up the tariff I have on automobiles or on pharmaceuticals or on
Signed off Sizewell C, big nuclear reactor, as well as small modular reactors in North Wales. So, that security for us is around energy security.
And just give us a brief overview.
Perfect. Hello, everybody. I'm so thankful for being here. This is my first Davos. And besides being a global shaper, like Irene said, I work at the Universidad Católica de Chile, where I promote, students going into research, especially in different engineering fields. But my background is actually in biotechnology. And I was presented to the world of synthetic biology, which I was so interested in, and just realized that it's not developed that much in my country, which is Chile. And that later took me to work in a different direction, more on applied science and developing a treatment for psoriasis based on products of stem cells, to just improve the skin disease of other people that are affected by it. Mm-hmm.
Great, thank you so much. Victor?
Did you want us to speculate on the life sciences in 50 years or something like that?
Well, we'll get to that. But maybe just give a little bit of background about yourself and your thoughts, just very briefly, and then we can get into the question.
Yeah, so I'm a basic scientist, meaning I have a PhD and I do research into animal development. And in fact, I've had a lab since 19 when was it? 1984 or something. And I've been funded by the U.S. National Institutes of Health for over 40 years to study the development of a little nematode called Caenorhabditis elegans, C. elegans. So it's a worm that only gets about 1 millimeter long. It only takes 2.5 days for its life cycle, but you can see every cell in the animal and watch every cell as it divides as the animal develops. And this has been an organism that folks all around the world, hundreds of labs study, and it's been the source of 4 Nobel Prizes from work in C. elegans. And so one of the things I'm here, I like to sort of see myself as a cheerleader for basic science and for the idea that there is an enormous amount still to be learned about living things. And I like to think of it this way, that probably there's more to be learned than we know about living things. There's probably more to be learned than we can imagine. And the reason is because in the life sciences, everything seems to be a surprise, right? And so daily, in the labs up and down the corridors of our university and your institutes and your university, people are encountering living systems with experiments and getting data that surprise them and cause them to challenge their presuppositions. And the dialogue in these labs and these institutes is so exciting. And so so we know in this moment, basic science research is unlocking new perspectives and completely new ways of looking at organisms. So I think that's what I want, I think it's very important to try to remind ourselves that we're not in this place where we've learned everything we need to know, and now we just need to apply it.
Great. Well, I'm going to get into the whole sort of how do we keep curiosity alive and the challenges to basic science a little bit, Victor, with you later. But Eva, please, over to you.
Yeah, thank you. And it's a pleasure to be here with such amazing panelists, and I'm sure many scientists in the room as well. So my name is Eva McClellan. I love this quote: I have no special skills except I'm insanely curious. And I think that is what drew me to biotechnology. I still remember being in grade school when we had 2 paper plates, and with spaghetti and pasta, we had to
of life, whatever that might be. There's always bad actors, and there's often a way to then abuse that discovery for, again, this negative outcome, and that's why we always refer to things as dual use. My own view is that we've got to get much better in universities, in training, and I'll come back to this with what you're doing, students, early career researchers, scientists, to in parallel think about what the consequences are of some of their discoveries. And I think we're seeing this writ large in AI and brain-computer interfaces, lots of different areas, where often it's out there and then we think, ooh, didn't anticipate that, and then we're trying to sort of We've got to get much better at this, and it's hard to think, frankly, in the life sciences of an area where we've actually done this well. I'd love to know whether the panelists think there is a good example where we thought about the ethical implications, the dual use. We developed the technology, but we put guardrails around it and we controlled it. I struggle to think of one, but maybe to you. So can we make the case for why we want synthetic biology and some of the sort of challenges that maybe some of these things bring, and how can we get better at sort of making sure we don't ruin the world?
Historically, I mean, there is the Sillamar Convention, which was in 1975 or whenever it was, where recombinant DNA had just been invented, let's say, and scientists were concerned. Mm-hmm. And so right at the outset, there was an effort, an organized effort to think about consequences. And that was gave rise to the NIH guidelines, on the use of recombinant DNA. And nowadays, I suppose that there's, in the CRISPR gene editing field, I can't really speak to this directly, but I mean, it feels like there has been a community reaction to, the one public case of editing children before they were born. And I feel like the community is thinking about it anyway, and trying to develop a consensus. If I could just briefly comment on synthetic biology, one of the things, I don't know if it qualifies as synthetic biology, but we're really excited by protein design. I'm sure you guys are too. And so, David Baker won the Nobel Prize for protein design, which was an incredible breakthrough. If you want a protein of a given shape, they can design the protein sequence and then the DNA sequence, and the organism will make it, and the protein will fold into the shape that you want. And so this enables us for the first time to really design new contacts inside cells, right? Which is kind of the basis for these circuits you're talking about, right? And in biopharma, there's a lot of excitement, I'm sure, as well.
There is, yeah, we call it like lab in a loop, how to design. And then I think it's exciting for many reasons, maybe to take that question around, what does it serve versus the risk? It's hard, right? Because self-driving cars, what's the risk, and what's the benefit? Maybe people who are, have disability could now transport in a self-driving car, and before they couldn't. You have to really look at the cost of the benefit of something versus its cost. So my point of view is, focusing on purpose and medical necessity, and I think that's really the essence. I mean, in healthcare or physicians, they have an oath, which is do no harm. And I think all of us think about that as human beings, hopefully do no harm, but how can you make progress from medical necessity? And not to pivot to Daniel, you can choose to, share your perspective, but this is very personal. When I talk to parents of children, I'm not a mother, but I talk to a lot of parents and children, and when they have a medical necessity, whether it's a diabetic or a hemophilic or something else, they're not thinking like, they're thinking like, do I share my data or do I not share my data? And I've talked to a lot of parents.
We have found that people in the Asian population cannot absorb alcohol as well. And it's known as the Asian flush. This leads to people that when they drink alcohol, they get a flush in their face. And they also can't digest this as much, so they get drunk very quick. That genetic mutation is known, and we could reverse that. It's very questionable if we should.
Yeah, well, that's a great segue. So what we've, just to conclude a little bit this section, as Eva and others have pointed out, we've got a great rich heritage, actually very based in Europe, for pharma. Many of the big pharmaceutical companies of the world were born from Europe and from European countries, built on chemistry from the 18th, 19th century. And of course, that's transitioned now. There's still obviously pharma, there's still a lot of need for medicinal chemistry, but biology has become this very targetable thing, and doing biology and creating biology, if you like, is now a fantastic, that's the sort of biotech, if you like, bioengineering industry and biologics. You'll have heard of all these words. So we are in this new era, and as you say, very targeted, for health benefits, which is, again, nobody's going to argue with that. There are some challenges that maybe we don't need to get into the weeds as to how you localize it. You spoke about microRNAs in a particular area, so there's some systemic problems. But this is the world that we're sort of in now, and I think we can probably all agree that that's a great thing. We've got more tools at our disposal to tackle some of these diseases that affect people. But of course, it can also enhance just life and the quality of life. And as we all are in countries where our populations are aging, most people don't get ill or don't necessarily get chronic diseases. They will eventually, but there's a great emphasis on having a much longer, better quality of life. And that's where one gets into, not necessarily that example you've given, but where maybe the synthetic biology or some of the other editing might be able to help facilitate a better quality of life, whatever that means for that particular culture or that particular country. Could you all say sort of whether you're going into that side of things, so transiting into sort of healthy living for longer as part of the industry, or maybe some of the research that you're doing, and what you see as some of the ethical implications that we should be thinking about now that we put in place? Because I take your point, Victor, that's a good example of the recombinant, and stem cell biology might be another one, but we're not very good at doing it globally. So whilst the country might do it, Britain took all the people who left America to come and do stem cell research in Britain because they could, because we had a different approach to the ethics of it. So as a globe, we tend to not go in sync. So there's still some challenges, I think, for us there. But who would like to start? Daniel, please.
So I'll give an example of the other side of the human population research. So in the human genetics research, so essentially comparing people's features at scale to their genetics, we have found that certain genetic mutations lead to genetic disease. we've also found, we, the scientific community at large, that certain genetic variants actually give a health benefit. So there's populations found, for example, in the US that have a 36% lower chance of cardiovascular disease, which is obviously very interesting because if we could all have that, we would suffer less from cardiovascular disease, which still is the #1 cause of death in the world. They were able to pinpoint that finding to one specific genetic mutation, so one building block in the DNA that was different in these people from everybody else. And this particular mutation is one that we could potentially introduce. And when we introduce that variant in animals that have a cardiovascular disease phenotype, we actually see that we reverse the phenotype and that these animals now restore a normal cardiovascular system. So I think that's a really good use case where you can introduce an edit to not therapeutically, but prophylactically prevent that people develop life-threatening disease.
Yeah, that's great. And Victor, I'm just mindful of the build-up of protein toxins in the prelude to maybe dementia. Can you see the microRNA technologies being focusing on very decades ahead of something becoming clinical or symptomatic that one could correct what one can see as maybe a trajectory that is going to lead to something down the road, and we should be intervening? And are you comfortable with that?
Well, in principle, would I be comfortable for intervening where it would increase the quality of life? Not by germline editing, though. We're talking about somatic editing or something like that. Or using an RNAi to knock down. You know, the thing is about these, whenever we talk about, let's say, these high technology, precision medicine modalities, whether it's editing of the genome or not, RNAi, therapeutics, these are expensive. And so one of the things we inevitably have to come up against is the issue that we can invent all these wonderful technologies, but if they're not available to most people on the planet, then that's a problem, right? It's not like a negative side, right? It's not like, this is a negative thing. It's almost like the thing we've invented is positive, but the problem before us now has become something that's societal, it's economic, it's humanistic, it's all that. But technologically, though, it need not be impossible, right? Because we can think about ways, right, to approach engineering these new therapeutics in a way where we're trying to anticipate accessibility and low cost and so forth, So I think that, I'm sure you all do that to some degree, but I wonder to what extent we may need, let's say, in education, let's say in a program, we in our med school, we have a program in translational medicine. I don't think that we take up really formally the issue of affordability. Engineering for affordability, now we talk about how, well, if you get the technology to work, then maybe the market will drive down. But the idea is, and now the modularity you mentioned as well. Now you've got to stop me.
Yes. You're on a roll.
A lot of these modalities are modular, right? And so you have an informational part of it, which is going to edit, or it's going to knock down, and you just design that on the computer, or maybe it's a synthetic protein, you design that. That's one thing. That's the thing that's going to interact with the living system to make the change. Then you have the sort of the formulation, or the little thing conjugated to it, the chemistry, that takes it to a particular organ. And so those two engineering challenges are the main sort of components. And the biggest challenge, from my understanding now, is the delivery component. The informational part is much more straightforward. So there's the opportunity for the engineering, bioengineering community to develop these so-called platform, you all can talk more about platform technology, where it becomes more straightforward to just sort of mix, as you mentioned, this with that, and you have a new thing. And if this is approved, and this is approved, this is going to be, if it's approved, it's going to be approved very quickly and cheaply. And so my colleagues that do this sort of thing at UMass Chan talk a lot about this.
No, it's a
very optimistic, I think, view of the future. But pressing on the need for the community, whether it's funding agencies and so forth, to deliberately try to promote these kinds of effort to really develop platforms efficiently so they're broadly available. Share data.
Well, I'll come to that momentarily, but you're absolutely right. I mean, maybe Natalie, you can comment on what you're doing, because obviously, you're at the coalface teaching the students. I'd like to know a little bit about what you're doing about ethical training as well. But to design right from the get-go, the capacity to scale and disseminate at pace and affordably, as Victor was saying. Are you doing that? Are we training the next generation of scientists and engineers to think in that way? Noting that different health systems are very different. So again, I think some of the challenges we got is that, I'm from a public health system. Obviously in America, things tend to be designed knowing that there's a middleman to take a profit. That tends to change the cost base. So there are challenges, but tell us what you're doing. Give us some hope about how we're taking this on.
Okay, so effectively, Latin America and specifically Chile's situation is very different. In this sense, I think that going for education and students and promoting, new interests in them, specifically democratizing science, making it accessible, easy to understand, because how will you be able to take part of a conversation if you don't understand the meaning of it and the impact it can have in a long time? So I think that's the first way to approach this situation. And I do also believe that at this moment, Latin America is behind. And that's the reason why with some other IGEM ambassadors, we're trying to create different initiatives in each country and also collaborate to spark that interest, show that it's possible, and, encourage young scientists and maybe high school students that are interested in biology and engineering and computing sciences to delve into this world. I think that the regulations of ethics and the decision making in the next few years is not entirely on the hands of scientists. It's very important to understand policies, governance, how to have different stakeholders being part of that conversation. So in this meeting at Universidad Católica de Chile, we have an undergraduate research program, which is mainly from the School of Engineering, but of course offers opportunities in different faculties. So in that sense, at this moment where I'm working in, each student goes after their interest, contacting a professor and getting to know more about a certain topic. It's just that not everybody's interested in politics and regulations and how it's going to change, but that's where I think the conversation is going, to know a little bit of everything, collaborate through academia and more experienced people with younger scientists, just like in this moment, to have the conversations. We have more technologies nowadays, but the expertise and different perspectives can create something that's stronger and can have a better societal impact in the next years.
Well, that gives us a tremendous amount of hope. And you're absolutely right about the need for people to learn the language of interdisciplinarity. I'm a big advocate that people have to be trained very deeply and specialistly, but they do have to learn the language of others and the courtesy and respect for other disciplines. And I'm a big advocate that people have to be trained very deeply and specialistly, but they do have to learn the language of others and the courtesy and respect for other disciplines. And I think one of the mistakes often scientists make is you think if you've discovered something and it's obvious and it's going to work, well, the world will just adopt it. And then you realize, humans get in the way and society, and there are anti-vaxxers and there are people that just don't want to adopt, energy solutions for the climate problem. And there have been many examples of that. And that's why we need our scientists to be comfortable to talk to people from policy, from social sciences, from humanities. And that's why a meeting like this is good, to get people comfortable with that. But the earlier I think we can teach people from undergraduates, the better. So I really applaud what you're doing there. Ava, have you got anything to say around some of these issues that we've just been talking around?
Yeah, maybe just that I'm actually quite bullish on technology democratizing access to medicines. And just two examples. So biotechnology is just technology as well. So every technology gets cheaper as it goes. I mean, how much did it cost to buy a computer in the home 20 years ago, 30 years ago? How much is it now? And so I think the human genome sequence, I don't know how much it costs to get a sequence now. What is it, Victor? Is it $200? How much was it when it first came out?
Oh, it was billions, wasn't it?
I wanted you to say that because you see the order of magnitude. So I'm really, really optimistic about technology actually improving the democratization. And just a little side note, before insulin, back to my insulin story, before insulin was, the protein for insulin was discovered and we could democratize it, only very, very few wealthy people could get access to it. You'd have to stimulate, I believe, the pancreas duct of a dog to produce a little bit of insulin. And only, the kings and queens of the state would be able to support if they had a diabetic kid. So I only share that here just to kind of give it this some weight. It's not just, it's not just empty words. Technology does allow us to do things in a way that it's then available to everyone. And then there'll be a new technology that will come out that, again, will take a couple of years or a decade to democratize. But I always say, everything we need is available. It's just not equally distributed. But over time, it will be equally distributed. And then something else will come that's not equally available. But I'd rather live in that world where we're moving that forward. So that's all I'm going to say about that. I was going to go a bit rambly into a story of, but I'm not going to do that. I'm going to reel myself in.
Well, we might come back with what that story is.
And I have to say it out loud just to kind of reel it back.
Stop yourself.
Yeah, and everyone, I am done.
We'll definitely pursue that one. But the point I think that Victor's making is, of course, we're getting quicker at democratizing the technology. Yes, the speed. But meanwhile, there is a gap. And that's an opportunity loss for either treating people or enhancing life. So how can we, right at the design stage, build it more cheaply so that it can, right out the gate, be something that can be widely disseminated? Is that mindset yet in your industries, or is that something we've got to just train a completely different generation to come forward to then hopefully join your companies and just do it differently?
I think access to healthcare, access to new therapeutics is front and center for every company that works in our industry. I think we're all very focused on the interest of patients and how we make sure that we actually help patients with the work that we do. It's difficult enough to be super frustrating that at the end of the day, when you succeed in developing a product, that it doesn't reach patients all over the world. So I think companies are really focused on it. The reality is that drug development is very difficult. It's extremely expensive. It's highly regulated. And as a result thereof, the failure rate of new therapeutic development is really high. And that feeds into significant cost for every product that reaches the market. I I think as we progress and as we look more into platform technologies that actually help to become predictive for every next truck on the same platform that gets developed, but also by implementing AI to help us fail early and really invest deeply and with high conviction behind the ones that have high probability of success, I think we over time can drive down the cost of development, and with that make access more equitable across the globe. So that's certainly an objective in my company, and I'm sure that's across the industry.
Yeah, no, that's fantastic. Well, listen, the time is going by very quickly, and I want to make sure there's time for the audience to ask questions. But at the end, just a heads up for my panelists, I would like you to just conclude each with a thought about the world you see in 2050 in terms of what excites you from your curiosity around, and let's assume that we're still really supporting basic science and its translation. What is it that you're excited about that you would like to see be there in 2050 in terms of biology? And that can be anything, it can be sort of, changing things on, we're all living on another planet maybe at that point, and what it means to do that. So you can be thinking about that whilst we open up for the audience for questions. I believe that there's a microphone, so if you could just say who you are if you're willing to say that, and we'll get started. Okay, so it's hard with my blinding lights here, but there's a gentleman here.
Okay, we have some lights.
Great, thank you. Yeah.
Hi, sorry, I'll stand up. Hi, my name is Wilson. I'm a law student from Hong Kong. I came. Thank you for delivering the talk. I just want to ask the panelists. There's been a lot of conversation about accessibility based on affordability, but I think we can all agree that increasing affordability for gene editing and all that technology is a good thing. It prevents rich people from hoggling all of that technology. But I want to pick your brains on the ethics. If we do include everyone, what if a person chooses to edit genes of, let's say, their embryos to make it have a certain condition? For example, currently there's deaf people prefer that their child be born deaf, and there's been cases where they explicitly request that their child be born deaf. So I wonder what your takes are on that. For example, this might be a case of being deaf. Maybe in the future it might be something else where they want the kid to be, something that's less therapeutic. I just wonder, what
No, it's a great question, and I'm only cutting you off so that we have time. If again, just everybody keep their questions really short. So I guess the question is, it gets into the sort of, determinism, free will, choice. Who has that choice? Again, particularly on dependence. Who'd like to take this on? Danielle, please. Yeah.
I think that's a real concern. I think you can use gene editing in particular for malicious edits as well. But I think that's the case with everything. You can use a brick to build a house, or you can use a brick to hit someone to the head and kill them, and it's clear that that's illegal. And I think everybody would agree that deliberately making a human being be born with a defect would not be what we as a society would accept. I think there should be significant regulation around that. And I know that when we for the first time saw someone experiment with editing in embryos, there was a significant counter movement across the scientific field against that. So I think it's really important to be aware of the risk that it imposes, and I think it's important to have sufficient guardrails around that from a regulatory perspective.
Yeah. Okay. Any other comments in the panel?
No, my position on that is quite clear. Just that's personal. Eva McClellan, personal position is you focus on medical necessity and prioritize things that you can treat and prevent medical illness or serious disability. And on the other one, I don't have another comment.
Yeah. Thank you. No. Yeah. Let's take a question from the back of the audience. So if we can go to maybe the woman in the middle there with a black sweater on. I'm just going to distribute around spatially as I can see it with the lights. Thank you. Please do stand up and say who you are if you're willing.
So my name is Ayana Kapler. I'm a high school student from Zurich, and I was wondering if gene editing regulations should be decided nationally, or do we need global rules to avoid ethical gene editing tourism, as we earlier had in discussion?
Right. Gosh, gene editing tourism. I haven't heard that expression again. Okay, who would like to take this on? Natalie, do you want to have a go? These are tough questions.
I guess regarding what was brought up before, I came into the biotech world because I really had a feeling that I wanted to do something that was able to create a good experience for people, to create something, a prototype, a system, whatever, something to impact people's life. I had the experience of working with psoriasis, and it's such a common disease that people only think it's like a skin condition, but it's multifactorial origin and it's multisystemic. It affects all of your organs and can have detrimental results if not treated accordingly. So in that sense, I do believe we have to use gene editing and creating, using synthetic biology to produce good for the people. I don't believe in, editing for obtaining a certain trait and trying to control things that I don't know, our traits make us unique. So I would encourage diversity, which is also how nature is. So I do stand with that, being able to use these technologies for doing good.
I guess it begs the question about what the social norms are of what we define, which might vary on countries, as to what's in that grouping that is a required a required disease, for want of a better expression, that needs a therapy, right? And I think there'll be different social norms for what a medical need is. And I think as we evolve and our expectations and our longevity improves, I suspect that bell curve of the norms of what's in that will change, and it will skew, it will grow. Victor,
Your question was more like, where would the decision be made also, right? National, and so one thing that just popped in my mind, I thought, okay, well, do we have an analogy? Do we have an analogy so one thing that just came to my mind was medically assisted death. Right? And then I was just quickly trying to go through my Rolodex of countries, not without mentioning them. I was like, okay, some have it, some don't. And then I had a little bit note around, how did they make that decision? And then, we use independent multi-stakeholder oversight to do that. And those multi-stakeholder oversight bodies, the best decisions use all perspectives. They usually are guided by ethics boards that include clinicians, that include scientists, that include patients, that include the community, and back to the norms and values of that country. And I have not sat in one of those boards on such a consequential decision, but I imagine it's a long process of finally deciding what's the thing. And I would also imagine that the public dialogue, similar to what we're having here, is critical in that conversation. If I was feeling super edgy today, I'm not going to do it. I would actually just say, show of hands, who would be for or against genetic tourism. I'm not going to do it, but if I felt edgy, maybe another time when I come back, I will. Because public dialogue, starts to also, citizens need to vote in realms of law, legality, and ethics that's been established in other parallel systems that were really hard decisions to make. And now, as I'm talking, I can think of 3 or 4 more, but maybe that's helpful.
It's such a good point you make, and I think the assisted dying is a great live example that we're going through in the UK at the moment with much discussion and debate, and that it emphasises that need to have, as you say, that dialogue, which is what, of course, WEF is all about on this particular meeting, and about the training and sort of this desire that how can we get better as scientists talking to the public and making sure, we serve them fundamentally, right? And we need to know how we need to serve you best and what it is you want us to do, as opposed to just leaving us free rein to come up with this stuff. Victor, it looked like you wanted to say something on this
I was
topic.
just going to comment that the question is so good because what it points out is these questions, they seem so simple, but they're so hard that the chances of getting an international convention on something like this is so remote. But it feels like each country needs to go through these conversations, through these processes, and each of us learns from the other as they go through their process. We're all trying to figure out how to be humans living on a planet, right? And we don't know how to do it. And so none of us can sit here and say this is the way it should be done worldwide. And so that's a messy business. How to be humans living on a planet, right? And we don't know how to do it. And so none of us can sit here and say this is the way it should be done worldwide. And so that's a messy business, is that each community, each country needs to wrestle and invent the process and teach each other.
Yeah, absolutely. Yeah, and your generation will be really facing, AI will be coming up with creative new biology, independent of any of us. So we won't be using it just as a tool. It's going to come up with something new, and that brings enormously interesting yet challenging questions. Okay, let's get another question. I'm going to come right to the front, as we haven't had a question. This gentleman here, and what we'll do is we'll take 3 questions. We'll try and remember them, and we'll answer them, please.
So, hi, how are you? Congratulations, was very amazing speech from your side. So, my name is Aramis Halbeisen, and I do political analytic and I work between governments doing lobby. So one of my questions is how can we make medicine more affordable for the countries that are not so developed and rich?
Great, that's a great question. Okay, thank you. So how do we make medicines more affordable for countries? Let's take a question from this gentleman here, and then we'll go to the very back and the lady at the back with the black sweater. Please.
Hi, I'm Herman. Thank you very much for the awesome panel. I'm a PhD student in Zurich. We spoke about ethics education and understanding that each technology is dual use. And so I was wondering, practically speaking, what needs to be done in the education system to include ethics education for budding scientists? And to what extent do scientists hold responsibility for their own discoveries? Thank you.
Right, that's a great question, thank you. And the lady right at the back of the black sweater, thank you.
Hello, I'm Lia, I'm from Romania, and I'm a youth advocate. I'm working with teenagers around the world. And I see a lot of, let's say, a lot of fatigue in students, in teenagers, overwhelm or lack of motivation, and a lot of lack of interest in health. So what would be the activities or the work or the steps that we will need to do as leaders in order to help the educational system to introduce this this kind of activity or systems in the school in order for them to get the information. Because if a parent gives the information home to the child, it's okay. But the majority of the parents, they don't take care of themselves, so they don't bring or give further this information to a teenager. So in order to have a sustainable performance on the long term, you need as well your health, your body, to start with your body. So how we can do that?
Yeah, okay, great. So we've got a couple of things that's around sort of the broad education thing. So one is around the sort of ethics and whether actually, the PI or indeed the algorithm, if an algorithm comes up with a new drug and it kills people, who's to blame? The company, the scientist, or the computer, or the mathematician that came up with the algorithm? These are real ethical questions that philosophers and ethicists are dealing with in the context of AI. So ethics, education, who's responsible if things go wrong? How do we get health education better in the school system so that people learn about health? Natalie, I'm going to turn to you first because you've spoken a little bit about this, but then if the other panelists would like to comment. And then we've got the more affordable medicines, which I'm looking to Ava and Danielle to answer. Natalie, do you want to start?
Sure. Regarding the lack of interest in students in health and biology or even STEM, I think it starts with communication. Sometimes it is so hard to understand using a niche word. Being in a niche and so technical. How do you translate that into something that you can understand, that you can keep in your mind, and you can do something about it? And regarding that, actually, because of iGEM, which is funny, I really wanted to be really involved in the lab work, but since our group was it wasn't heterogenic, let's say, between 12 to 13 people over the team were only biotech, so that is also a huge bias on how you want everything to work. It's important to have diverse backgrounds and information, and I encountered the communication coordination of our team. So doing that, science communication, which at the time I didn't know it was called that way, just made me be able to transfer these ideas to communities, even speaking with kids, maybe 4 or 5 years old, until, grown-ups from rural areas around Santiago, that's my city. So I do think it starts changing the content, making it accessible and understandable. And so also I want to delve, hopefully next year, and how to create content that is also entertaining, that is fun, that you don't associate it to being boring, but sparks curiosity. So I think it starts there. And for that, I've known that there are more formats. So there are video games, there are magazines. And I actually discovered a couple of years ago, Frontiers, which is also promoting open science, has an initiative that they conduct articles that are written by experts but edited by kids. So I think it has that input of youth and it makes it more fun and closer for them to understand.
Yeah, it's a great answer about the dissemination. And I think, my sense is I've just recently finished being president of the Federation of European Neuroscience Societies, and neuroethics is an area of concern because of just the manipulating your mind as something that people find very threatening. And, we brought in neuroethical training and it's so popular. So my sense to the gentleman that asked the question is the people want to be trained. Students, postdocs, early career researchers, alongside their work, they actually are welcoming the opportunity. So I think academic societies that you're members of should be laying on, as part of the conferences, as part of the educational training, they should be laying on ethical training as well. Can I just ask my industry partners very briefly, because then we need to conclude, how do we make medicines more affordable?
I think AI will really help us to accomplish it. I think I mentioned it earlier. If we are able to drive down the failure rate, increase our probability of success of the molecules that we invest behind, that will lower the cost of drug development and ultimately will lower the price of the products. I think it's important to realize, though, that currently medicines, when they are approved, have a significant price tag, but only for a short period of time. When the patent expires, they become what's called generics, and they become typically readily available at a very low cost to society. So the majority of our medicines actually are very affordable. I think AI will help us to get new innovative medicines to be more affordable at launch.
Yeah, fantastic, great. Well, you've been great as an audience. If you can indulge us maybe an extra minute over time, so thank you for your questions, and then we'll appropriately give a round of applause. But before we do that, one more task for our panellists, and that's just to go along, maybe start with Natalie, as to what do you see as the future for biology in 2050, and what is it you'd like to see? What are you going to be particularly excited about, hoping will be the case?
Well, I'd like to see more youth in STEM, especially girls. In Chile, it's maybe in STEM careers, around 30% of girls that are participating. So first of all, there's that. And then, being able to encourage youth, giving them tools, and the space also to have hands-on experience and also get to know what other stakeholders think and how they can engage and create collaboration. So for that, just, my university does that by a program, inviting people from different sectors and trying to explain what they do to students. So I think that's the start. And just for 2050, I just want to see a better world.
A better world, yeah.
Also, biology in 2050. I mean, what jumps to my mind is by then, I hope we will have detected habitable worlds in other star systems and detected the signature of life there by then.
Yeah. No, I was hoping somebody would give that sort of answer, so thank you, Victor. Ava.
2050 on at 65. I hope that we don't use the word women's health anymore. I hope that half of the world's population is living not only longer, women are living longer, but they're living less well in the last 20 years of their lives. So my wish for half of the human population would be that women would continue to live as long as they live, that the lives that they have would be with better well-being and health, and that we would understand the genetic differences, sex differences as it relates to response to environment and medicine. We've solved that, and women's health is no longer a topic.
Fantastic. That's a good one. Great.
With better well-being and health, and that we would understand the genetic differences, sex differences as it relates to response to environment and medicine. We've solved that, and women's health is no longer a topic.
Fantastic. That's a good one. Great. And Daniel?
I think my hope is that by then we understand our therapeutic platform so well that true personal medicine becomes a reality. And we can be so predictive that we can treat people with new medicines without lengthy validation processes and trial and error. It goes straight to a solution. And I think that's potentially within reach.
Fantastic. Brilliant. Well, can I ask you please to thank our panelists, to Natalie, to Victor, to Ava, and to Danielle. It's been absolutely wonderful. We wish them well in their work going forward, so keep up the great work, and thank you for the contributions you've made to science and to the betterment of society. And thank you all for coming, and to the organisers. Thank you so much. Oh, my pleasure.
Could you ask if I could have a quick